Hello friends, today I am going to reveal some true facts of Stephen Hawking's universe. Hawkins tackled the biggest question of all. How did the universe begin? But first of all, I request you to please share and subscribe my channel for getting my informative true facts videos uninterrupted. Please note that subscription of my channel is free of cost. Now, Stephen Hawking's universe. Hawkins tackled the biggest question of all. How did the universe begin? With the death of Stephen Hawking, the world has lost an adventurer. I am going to give you the exact wording of researchers. I was one of the many who first encountered the deep ideas of cosmology through Hawking's book, A Brief History of Time, and found myself inspired. To his readers, Hawkins revealed a whole new world, showing how physics can address some of the deep questions of our existence, all the way to the deepest of all. How did the universe begin? How did the universe begin? Physics is often perceived to be dry and devoid of imagination. But as researchers, we realized that could not be further from the truth. In research, we routinely throw assumptions in the bin, play with what if scenario, and rely on insight and creativity to explore new ideas that could take us beyond the bounds of physics we already know. Stephen Hawking was a master at this. Now, theory of everything. What made Hawking such a trailblazer where he attempts to merge quantum physics and general relativity? The situation in modern physics is both powerful and dire. We have two incredibly strong theories that have passed every test we can throw at them, and yet we cannot unify them. General relativity is our theory of gravity, with thanks to Einstein, and quantum physics is our theory of everything else. In particular, how particles interact. Both have been tested to incredible precision and have become everyday tools. We use general relativity to make our GPS system accurate, and quantum physics is to design key elements of all high technology. However, we still have no theory that combines the two, and this has perplexed physicists for a century. Merging the two theories engaged Einstein for the latter half of his life to no avail. The quest for a quantum theory of gravity that can be explained the whole universe is known as the search for a theory of everything, or TOE. The quest for a quantum theory of gravity that can be explained the whole universe is known as the search for a theory of everything. Hawking's most famous insight was to take seriously the question of what would happen if you took a quantum system and put it near the event horizon of a black hole. Even without a final theory of quantum gravity, he revealed that in some special circumstances you can calculate solutions anyway. Now, the mind of God. Hawkins famously described the quest for a theory of everything in analogy to God. If we do discover the theory of everything, it would be the ultimate triumph of human reason. For then, we would truly know the mind of God. He was first to explain this line many times. As a devout atheist, he made it clear that he didn't mean he would understand a deity, but rather that we would be able to explain, using physics, the birth of the universe itself and all of the process within it, thus demonstrating there is no need for a God. In his own words, God may exist, but science can explain the universe without the need for a creator. This is the wording of Einstein, the wording of Stephen Hawking. As per Stephen Hawking, God may exist, but science can explain the universe without the need for a creator. how the Big Bang banged. We know that nothing, not even light, can escape a black hole's gravitational pull. Nevertheless, Hawkins discovered that black holes should glow. The light they emit is now known as Hawkins radiation. But if light can escape from black holes, how can they glow? Light cannot escape from the black holes. How can they glow? The event horizon of a black hole is the point of no return. Once you are within the event horizon, you can never escape, and no light you emit will ever be seen outside. The reason black holes can glow is because no light actually emerges from inside the event horizon. The light gets created just outside of it, thanks to the black hole's interaction with the quantum vacuum. This leads to another question, because another important rules of the physics is the conservation of energy. You cannot create something from nothing. You cannot create something from nothing. So in order to glow, the black hole has to pay a price, and it pays with the only currency it has, its mass. As the black hole emits light, it gets lighter, and the lighter the black hole, the more dramatically it shines, which accelerates its demise until it evaporates into nothing in an intense flash of radiation. As spectacular as that may be, it may seem a trifle esoteric. Why should we care how black holes behave? Well, the theories Hawkins was developing also have implications for the question of how the universe began. Hawkins proposed a mechanism through quantum physics by which the universe could be born. In other words, he proposed an answer to how the Big Bang banged. The symphony of space. The symphony of space. Hawkins became one of the world's most recognizable physicists. His fame saw his appear frequently in the popular culture, including on The Simpsons and Star Trek, where he played himself. Not only a superb researcher, he was a brilliant communicator, and this set him apart from his peers. His brief history of time sold more than 10 million copies and was translated into at least 35 languages. One of the fantastic things about A Brief History of Time was that it made complex ideas simple, but also didn't shy away from giving the gory details. Hawkins showed respect to his readers and to this potential to understand, perhaps having higher expectations of them than they had of themselves. As a result, he was able to convey a great feeling of the depth of thought behind the theories. Millions of readers engrossed in his book left with a sense of wonder. Even if they fell short of full understanding, like listening to a symphony, you can appreciate the beauty and complexity of the music without knowing how to play any of the instruments. Hawkins played the symphony of space into words on a piece. This left people with the feeling they had experienced something profound, even if they hadn't fully understand it. Be curious. That Hawkins survived until age 76 is truly remarkable. Diagnosed with amyotrophic lateral sclerosis (ALS), as a 22-year-old, he was given only 2 years to live. Rather than being defeated by such a diagnosis, he dove into research with an urgency perhaps inspired by his limited time. He determined to do something significant with his time remaining, and thus attacked some of the most profound and challenging questions in physics. To the benefit of humankind, he did not succumb to the disease and was able to continue researching for another half century. That he refused to let physical difficulties deter him from his life's work is an inspiration to us all. He was also a real character and is famous for placing high-profile bets on his physics question, which he usually lost. In 1974, he bet that the X-ray The source at the center of our galaxy, Cygnus X1, was not a black hole, but considered the loss due to overwhelming evidence by 1990. From our modern perspective, it is astonishing to realize that all of his early research on black holes was done before we were even sure they existed. One of Hawking's most fascinating bets was about the information paradox. Information paradox. The fact that black holes can evaporate turned out to be extremely perplexing because all the information about what went into them is lost as a black hole vanishes. In quantum physics, you can't destroy information, thus the paradox. Although Hawkins considered this bet very publicly in 2004, most physicists would still argue that the answer is unresolved. Recently, it has seen a resurgence of interest with the firewall paradox, and Hawkins himself was adding new ideas to the debate even in his last few years. As we say farewell to one of the greatest thinkers of our time, I leave you with some of his best advice. According to Stephen Hawking, look up at the stars and not down at your feet. Try to make sense of what you see and wonder about what makes the universe exist. Be curious. All these are wordings of Stephen Hawking. Look up at the stars and not down at your feet. Try to make sense of what you see and wonder about what makes the universe exist. Be curious. With Stephen Hawking's passing, humanity has lost a brilliant mind and inspirational human being. In my next video, I will reveal some true facts of other more interesting topics. Thanks.